Okay.
So that you're not doing so that you're not doing nothing over there. I'll get the quiz up and running for you, just so you can see it, and then I'll go over the corrections there. And that's what we can do, at least while you're over there on the other side of the planet. Okay. So Zoom, you can see that okay, or is it too small there?
It's small little bit.
Small, okay. Well, let's make it bigger then. We'll do something like that. Something
Yeah.
like that. All right, beautiful. All right, so taking a look at these questions here. It says simplify the following, right? So root 75 there to start with. So when you have root 75, what you can do is you can write it so that it has with square numbers on the inside. That's a big list of numbers. That was like 1, 4, 9, 16. So 75, how can we write it with a square number on the inside there?
25 and 3.
Not bad. A few answers from class, a couple from Zoom. So one possibility that I heard is 15 times 5, and the other one is 25 times 3. You all see that okay? Oh, that looks beautiful today. What the heck? It's awesome. Okay, so for this to work, what you want to do is use square numbers. 15 is not a square number. There isn't a number times itself, a nice number that is, times itself that gives you 15. 16 is 4 times 4, right? Same with 5, that doesn't work. So this is the style of answer that you want there, okay? So instead of 75, you write it with 25 and 3 because 5 times 5 is 25. Good. The what do you then do? Just like we done before, split it up into 2 separate parts. 25 and root 3. And so we get 5 root 3 is our final answer there. Yeah. Yeah. Right on. The next question, what do we got? Busy. 288. Over root 8. So there's a couple of ways to do this one, just like that one. These numbers are getting big though, right? So maybe what we can do is use our other method, prime factorization. Okay, so we'll break down these numbers, cancel out what we can, and get a good looking final answer there at the end. So the number 8. Yeah. Oh, I drew a triangle instead for some reason. 2, 2. There we go for number 8, right? Okay. So we have 2 times 2 times 2 for 8. We'll put in there. 288. That's gonna be quite a bit bigger. Okay. So what's one number we can use to start with? Let's choose prime ones. Let's choose easy ones. 2 for sure, right? Okay. So 2 times what gives you 288? Nice. Heard from class, a couple from class here, 144. What next? Two numbers that multiply to give 144. 2 and 72. Yeah, not bad. What next? Yeah, from class. Ah, so from class, we got a question is how do you know which numbers? Well, that comes from knowing some, so you can think of it as multiplying. So 2 times what gives you 288? Yeah, okay. So in class we got, oh, there's so many numbers. What do you do? Well, the one thing is, yeah, so Zoom in class, we're talking about how to figure out this 288 here. How to get these numbers. So there are some tricks. Notice it ends with an 8, right? So that means it divides by 2. So then off to the side, what you can do is go 288. 288 divided by 2. You just work that out separately. Okay, and so to divide, yeah, Casio might be there. If it isn't, then you can do long division if you remember that. Yeah, so you do that. So 2 goes into 2 how many times? Once. 2 goes into 8 how many times? 4. 2 goes into 8 how many times? Okay, so there it is. 144. Yeah. Okay. So we do the same. We get 2 and 72 now. Hang on. Yeah. Let's just admire it first. Right? Ends with a 4, so it divides by 2. So we can do the same thing down here. And we'll get an answer of 72 showing up, right? Okay, so now we got to break this up within the
This is
space.
by 2
Yeah, by 2 again. 2
and
with what?
36.
36 from Zoom, from class, confirmed? Yeah. Okay. My tree is going to explode a little bit like this now.
And also divide by 2, it gives 18.
Yeah, so Zoom, they're saying 2 and 18. They're already keeping going. From class, what did you say? 6 and 6 can work? Yeah, I'll do that just for fun.
Mhm. Yeah.
Someone said 3 and, or 2 and 18. That also works. Okay. What do we get though? 2 and 3 for the 6. See? So a bit messy on account of how I organize the side work here, but hey, that's how it goes. So now watch. We're dividing all these, right? So 288 is the same as all of these prime numbers now multiplied together. So that's 1, 2, 3 for 5 2s, for 5 2s, and then 2 3s multiplied together like that. Okay. From the 8, we got 2 2 2 like this. Yeah. Okay. Now, this is a fact from square roots. When we have them separate like this, we can combine them all together into one big square root. So we can make it tall like this. So on the inside, what do we got? 5 2s showing up there. 3 and a 3. And then on the bottom, we got 1, 2, 3 2s like that. Okay. Notice now what we can do with these 2s. Those can divide out. Those can divide out. These can divide out. And what are we left with? 2, 2, 3, and 3. Now going back a few days, yeah, we can take our square root now. We're taking the square root. So we want groups of 2, right? So these 2 2's turn into 1 2 on the outside. Those 2 3's turn to 1 2 on the outside. And they're not added together, as I saw in the quiz from one of you. Multiplied, right? Yeah. Final answer, 6. Okay. Good. Okay. Now, this is one way to do it. Once you start getting good with these numbers, you might you might answer that question like this instead. 288 over the square root of 8. So this is probably how I would do it, just because I got some numbers in my head, right? I know that 288 can be written as a square number, which is 144. I know it. I know it from the list. Oh, there we go.
Yeah.
144. Square number that I know from the list. And, well, the 2. Okay, and the 8, we've done it enough times that 2 root 2. Although, if you do need a reminder, I'll show that in the next step. Writing 8 as a square number with a square number, 4 times 2. Let's do that first, okay? We said we can, in this case, because I'm answering it differently, instead of making a big, tall square root like in the other question, I'm going to split instead. So you split the square numbers away from the other ones. Okay, so not big and tall this time, splitting instead. Beautiful. What's the square root of 144 from the list? Close. 11 is 121. 12 gives 144. Nice. So the square root of 144 is 12. No square roots there. On the bottom, what's the square root of 4? Or another way of thinking about it, what times what gives you 4? That's sometimes easier. 2. See? So that means 2 is the square root of 4. That's how you think of that. We still got these square roots there, so those can divide out. Could have done that up here, actually. I was just busy talking. And then 12 divided by 2, 6. Yeah, in a different way. Okay, both are good. Faster is better, but correct is more better. Yeah. Okay, that was the first question only. Let's keep going through this here to see what's next. Mm-hmm. Oh, that was the second one. See, with this one. With this one here, we got a 2. We got a root 10 and a what? Root 8. Gotcha. Okay. So for this one, 2 ways to do it. There are a few ways to do it, actually. What's one idea that you have? What's one way to solve this thing?
For me, I put on square roots 2 and 5 and 5 gives
Well,
10.
from Zoom, they say work on the square root of 10. That's okay. So I'm going to do that. That's true. So this is
And
like, and 8, they're saying. Okay, what do we get for 8?
2 times 4.
2 times 4, sure. We can do it like that. This is kind of combining the two different steps we did before. We got a square number in there, which is fine. And then we got a bunch of prime numbers there, which is also fine. That's good. Okay, so what do we do next? Myself, I see this as a square number here. I would split that first. So we get that still on the inside. That'll be 2, and then the square root of 4, just keeping it all in order there. Let's see. Checking my work. No, this looks good to me. Because all we're doing is splitting up this term. Like that. Yeah?
Yeah.
And now doing some work. What's the square root of 4? 2 for sure. Okay, so we're getting there. Again, we can, with this idea, it's good. There might be a shorter way to combine some steps together, but this is what we got right now. So look at that. We got 2 on the outside, 2 over there. What happens with those? Those can be multiplied together with one another times. Okay. So that creates a 4 like that. And that like that. Getting there.
Okay.
What can we do next? Well,
Split it 2 and 5.
2 and 5, if we're looking at those, there's no square number on the inside, right? So it's kind of finished. But look at this, we got a 2 over there. What we can do, watch, is if we multiply these together, then they all go underneath. They all go underneath the same square root that is there.
Oh, yeah.
Right? Instead of splitting, it's combining instead. And now, because it's a square root, we want 2 numbers the same to go out. The circle time, right? So we got that number and that number. Those 2. They can go to the outside now. What do we get then? Yeah, nice. This 2 shows up there from class. We got this. That's true. Final answer is not 6 root 5. The final answer is what? Hey, 8 root 5. All right. Now, with that in mind, when I see these numbers, this is how I might do it. My first thing I look at is I see 8 times 10. You know, we can combine those together into one square root. But root 80 isn't anything. It's not a square number. So for me, that's not so helpful. So what I would do right away is probably something like this. And then I would combine them all together. And it would just look, it's basically the same, but just faster. So watch. I got a 2, a root 10, and then a root 8. So I would see a 2 on the outside, a 2 and a 5 from splitting that up. Then I would go all the way down, 2, 2, 2 like that. Combine them all together now. Groups of 2. Okay, so maybe it's not that much faster. Maybe it's about the same. That's what we're looking at. Yeah? Something like that. Okay, beautiful. That was the first question there. Oh, D part now. But this one, these radicals, they all look different from one another, right? But you simplify, so that means you can't add them together at this point. They're different, doesn't work. So what you do is what we just did. Simplify them and then see what happens. Maybe there is a connection between all of these 3, or maybe 2 of them, right? And I happen to know that there are. Made it that way. Okay, so we can do square numbers for some, primes for some, right? However you like there. I'll do 2, 2, 2 for this one. Oops, not equals, plus. I'll do 16 times 2 for that one. And then what times what gives me 27?
3 times 9.
3 times 9, nice. 1 and 27 as well, but it's just, that one's silly. That one's not helpful. It's true, but it doesn't help move forward.
Mhm.
I'd have to give you marks if you said that.
Me?
Okay. Well, half a mark.
Mm.
Okay. The first one. What happens with the first thing? Those 2 go to the outside, left with 1 on the inside. Yeah. Okay. We got a square number now. What do we do here? It will be 4. I'm going to show the split first. Okay. Next step, to give you credit, absolutely. 4 is the square root of 16. Okay. And then what's this one? Someone said 3 times 3. Yeah. So that's getting a little bit ahead there. Sort of skipping, doing this part in your brain. Absolutely. You do the split. What's the square root of 9? 3. Just like that. Okay, so now let's fill in the other parts so that we're not jumping around and everything. For this one, that looks good. 2 root 2. For this one, that turned into the 4, so we have this root 2 sticking around still. And this last one is just backwards. Usually we write the number on in front and then the root afterwards. So it's backwards like that, just going straight down, right? We're going to clean it up so that it looks professional. Number in the front, radical in the back. Beautiful. Final answer, what do we get? Notice those are the same, so that they combine, but that one's different. That's a radical 3. It's different than the radical 2s. So it's going to stay separate there at the end. Okay, now how about those? Yeah, it's going to be 6, right? 2 bananas plus 3 plus 4 bananas, 6 bananas. Okay. There we go. Success. Any questions about that one? No. Parsa and Ben, you guys need something else there? You guys got this all sorted? Did you finish your homework questions there? Did you- Okay, so the question about the question is going to have to wait. But you have this from last day. You want to try that? This is pretty crazy. We'll get the earlier work done first. We'll get this practiced and then this comes after. Okay, so I'm going to hold on to it for now.
I know how to do that, but I don't know how to explain it in English.
Aha, well,
Yeah.
then that's your task. Okay, back to the quiz. Zoom is just listening to us. Well, not listening and not really knowing what's going on. Okay, so that was the first one. Peter, that goes for you too, actually. If you're okay with the quiz, you can take a look at this from last day and try and help out your math teacher here. Okay, beautiful. These ones here. When you have terms being multiplied like that, what happens to the exponents? Right. Now, as a reminder, this 4 means there's 4x's all multiplied together. So explode this out in your, expand that out in your head. Okay. And same with the 6. There's like 6 of these x's all multiplied together. So how many in total then? 4 here. 4 there. 6 there. So how many in the line are all multiplied together?
10.
Yeah, nice. From Zoom, from class, we got 10 altogether, right? So remember, you add these together, add in this situation in order to get the result. That's the little shortcut. Add the originals to get the number there at the end. So when it's multiplying,
So I have to put all the axes and multiply. I put just the plus between
yeah,
the boxes and get them.
this is just to show it. You don't have to write that out, but it helps sometimes to start.
Okay.
You can go from here. Actually, this is how the good looking answer would be. That's what you got. You recognize, oh, in this situation, because it's this first term times the second term, that means you add the exponents. So show that you add the exponents. Good looking answer. Shows everything there. Yeah. For dividing, the next one, it's going to be, dividing is the last one. Okay, for B. That was for A. Yeah, from class, we got the answer. In this situation, with the bracket in the middle, these get multiplied together. So you get x to the 15. Okay. One step like that. The way to see it is that there's 5 of x3's multiplied together. You got x3 times x3, 5 of these, right? And so how many x's are here? 3 of them. How many there? 3. So how many in total? 15 will be there in total. Okay. For C part.
I split it them like X separate and Y separate.
Yeah, I got that. Okay, so how this works. Yeah, Zoom is, our class is saying the same way as B part, almost. What you gotta do is you gotta split it first.
Yeah,
Okay.
that's okay. I
So
split it.
you split each term. Then each term gets the 3 that's upstairs like that. Yeah. So here we do multiply x to the
Yeah.
9. And here we multiply as well, but we don't get 24. We get some, oh, we don't get an x either. Stays as a y. Y to the what? No multiplying here. 7 with 3. 21. Thank you.
And 3 times 3, 9.
Oh. So we split them and then multiply together. 9, multiply together. Not 24, as someone got. 21. Without the big blotch, if you don't mind. Okay, then the last one. The last one there's with some dividing. You can do 2 things with this one. First thing you can do is work on the inside and then split it. Or you can split it first and then simplify afterwards. Okay, the last one with the x's there. Looks like this. I'll show you both. You got x3 over x to the 3 rather. X to the 5, and it's to the power of 4 there, right? Everybody can see that okay? Not. There we go.
Yeah, now. Thank you.
Okay, so if we do the inside first, then we have x to the 3 and x to the 5. What will the inside look like?
X power of 12 over x power of 20.
That's if we had 12 and 20. That's if we do the splitting first. What I'm saying is simplify the inside first. Someone else wants to do the splitting first. I'm doing 2 different ways. Inside first and then the split. Okay, we'll do the split first. These 2 people have said it. What the heck? So we split it up. Top. And bottom. And then, yes, multiply in this case to get a 12. Multiply in this case to get a what? 20.
Mhm.
Right. And then we simplify here at the end.
1 over
Mhm.
8.
I don't know. Could be 20 minus 12. Yeah, kind of. You just got to remember where it goes. What is 20 minus 12 there? That's what your fingers and toes are for. And your friends. 8, that's true. Okay, now does it go on the top or on the bottom? Bottom, because there's more X's on the bottom than on the top, right? Okay. So in my brain, I got 12 X's, 20 X's. So more of them are going to end up on the bottom. So all the X's are going to end up on the bottom. How many are there? 8 for sure. Okay, so that's the final answer when you do the split version. Okay, divide into top and bottom, work out each part, and then get through to the answer. Okay, for the inside,
5 minus 3, and then it's like 1 over x power of 2, then we times 2, both of 2 and 4, it's 8.
true, a lot of words, but I think they're right. So just like down here, we did 20 minus 12 and we put it in the right spot, eh? We can do that in the very beginning. We can subtract here, right? We can divide, subtract the exponents. We can divide the terms with one another. So here we did 20 minus 12. Here, what are we going to do? 5 minus 3, right? So what do you get? 2. Now, are they going to be on the top or on the bottom? Bottom. There's more on the bottom, right? There's 5 of these things on the bottom. So x to the 2 will be on the bottom. 1 on the top just to hold it, right? So that's doing the inside first. And usually it's not bad. Makes the numbers small and nice to work with. Okay. But now we do have to split it up now. So we get 1 to the 4 on the top. And on the bottom, that gets the 4 as well. Okay. So I'll do the hard one for you. In this situation, these exponents multiply, so we get x to the power of 8, right? You guys have the easy one. We have 4 1s multiplied. I thought it was easy. 4 1s multiplied together. 1, 1, 1, 1. So what's 1 times 1? Oh, times 1. Oh, times what? What do you get? Same answer. Okay. But be careful about this. Would that be an exponent? Yeah, it's not 4. Ends up being 1. Okay. Beautiful. Any questions about that? No. Okay. Go over here. Prime factorization. Yeah, that was just for fun. Let you guys show off a little bit. All right. So what is the what's the first one there? What does that factor down to? No, 288. We've seen that already. Anyone happen to remember? Yeah, what'd you get? Close. Which one? Four. There we go. Right. Next. 2 and 72. That's true.
236.
Maybe. 2 and 36. Is that the one you want to use? 63? No. That's a 9 one, but
9 and 8.
we had a 3 in there. But 3 times 6 is 18. Okay. See? 2, 3, 2, 3. Okay.
Did you say there 72 is 9 times 8? So
Yeah.
where's the
We could have gone 9 times 8 here. And that's kind of what I was hoping for. It would be neater, I think, but more symmetric. But hey, not wrong. We're good. So final answer, though. We got a pull out all the prime numbers that we got, plus these ones down here. And so we get 2 to the power of 5, because there's 5 2's there, times 3 to the power of 2. Just like that. Fantastic. All right, now we got the next one's 132. It's a little weird. Oh, no square roots either. Some of you put those in there by habit, accident, not sure, but careful with that. So here's a trick. I think I mentioned with the 3's, right? 132 so big, I have no idea. But if I go 1 plus 3 plus 2, I get a smaller number. What's 1 plus 3 plus 2 equal to? Good. 6. Does 6 divide by 3? Yeah. Nice. So if 6 divides by 3, 132 divides by 3. I'll say it again then. This is what we're going for. 132, too big for my brain, I don't know. But if I add those digits up, I get a smaller number that I know stuff about. Does 6 divide by 3? Yes. So that means 132 divides by 3. And then we just got to figure it out. Okay, so 3 and something. No idea. So I'd go off to the side, do something like this. One way to do it, 4, 12. 2 comes down. Yeah, happens to be 44. You knew that? Huh. Could have told me. Keeping it secret.
And 2.
Yeah, a couple different directions. I'm going to say 4 and 11. 2 and 2. Perfect. So final answer. I was thinking square roots again, actually. And this is, look, that's dividing, not square root. You know, but myself, I was just going to, square root 2 is on the outside. No. Final answer. Be sure you answer the question. That's what it is.
Oh,
Yeah. Indeed, that's what it is. And what's the last one? 423. Wow, strange number. Strange for me, at least. But I see a 3. I'm going to check the 3 trick. 4 plus 2 plus 3 is 9. Hey, that divides by 3. That will divide by 3. Just got to figure it out.
yeah, it gives 141.
141?
Yeah.
That goes 1. 3 goes over. 4 is there, and then a 1. Yeah, that's true. Well, now we got 141 to deal with.
3 it gives 47.
Oh, Zoom says 3. I'm going to check it. 4, 5, 6. Yeah. Nice work, Zoom. 3 and then what then?
47.
47? I don't know.
Yeah.
4 for sure. That makes the 12 comes down to, yeah, nice. That's an arrow for coming down. Creates the 1. 7. That's good. Okay, so going from the list, I'm going to trust you. 47's prime. Final answer, 3 squared, 47. You know this, remember? You can come to the party, right? Phone call gets connected. Otherwise, doesn't work, right? Oh, this looks a little strange. I'll put a times in there. Otherwise, it's some sort of new invented type number.
I put 3 squares 47. So
Yeah, exactly. 3 square,
that's
just off
fine.
camera there. But yeah,
I
perfect.
didn't look through. Okay, it's okay.
Oh, yeah, yeah. No, it's just for class. That looks better than on the camera. Yeah?
Oh,
Yeah. Okay, so that was the quiz to go over. Let's see. I want to do this with fractions because then everyone can get started on this, even the Zoom folks. Okay, so I want to show this one thing with fractions. And then you can get started on that. Some people have questions about their homework. We can do that. Let's give you a break from my chatting here. Reducing fractions. Here's what I'd like you to do. Once you start, after a while, you start seeing some shortcuts and such. But for now, this is what we got. Okay, so reducing fractions and then, what did I just say? Reducing fractions, right? Okay, so what it means is like this. Let's say you have 4 over 12. What is the simplest fraction that you can write this 4 over 12 as?
12 divided by 4, and then 1 goes up, and the answer goes.
There's a way of figuring it out. Happens to be 1 over 3. Okay. All right, now here's how you can do it. Prime factorization, I'm saying, and then some dividing. So hang on a second, just watch this. With the 4, what's the prime factorization of that? Yeah, it's nice, eh? 2 and 2. With the 12, what do we got?
2 power of 2, so 2 times 2 times 3.
Yeah, I'm going to write them out. Yeah. Okay. And so then watch. 4 over 12 is now the same as 2 times 2 divided by 2 times 2 times 3, like that. See? Just replacing. And you can be way more efficient with your space than I am. I'm just showing you all the individual steps, right? But what you do now, that's the prime factorization is done. Now you just divide whatever you can. What's 2 divided by 2? 1. It's gone. What's 2 divided by 2? 1. Okay. And then you multiply, you simplify whatever's left over. So on the top, you have 1 times a 1, which is a 1. And on the bottom, these are gone. So what do you got? Yeah, you got a 3 down there. Finish there. Not yet, because I want to give people pieces of paper. I want Zoom to be looked after, and then we can. It's coming up for sure. Okay, so this is what it means by reducing. Zoom, you had a question?
what happened?
One more example.
Oh,
It's something good to be good at. Let's say we got 56 divided by 16. You have to reduce this. Make the numbers as small as possible. What's that? 4 times 4 is 16. Yeah, that's true for the bottom there. Now let's go all the way down to primes. Okay, so 16 is 4 times 4. If you go all the way to primes, what do you got? True. I'm going to write them out, though, for this reduced stuff. No exponents. You can if you want, but for me, just to get started. That 4 turns into those 2's. That 4 turns into 2 more of them. Beauty. What about the 56?
8. times 7.
8 times 7, Zoob says. Nicely done. Getting it down to primes.
8, 4, 4. Okay.
Yeah, so primes, right? As you saw, you can get faster. We could have done 8s. I'll show you, right? But down to primes will always work. What happens to these 2s? 2 divided by 2. 2 divided by 2. 2 divided by 2. Final answer? 7/2, right? Nice. Just like at the park. Hey, do you want to go faster? Here's how you can do it. 56/16. 8 times 7 or 7 times 8. 16 is 2 times 8. See? Yeah. As soon as you get the same number on the top as on the bottom, right, then they can divide out with one another. All right, and what do you get? 7/2. Not bad, eh? Okay, so this is what we're gonna be doing. In class, I'm gonna give you out a sheet that has a bunch of these to do, and we'll correct it before you go. Zoom,
Mm-hmm.
it is, yeah, it's on Teams already. So you
Okay,
get,
day 11.
yeah, day 11.
Mm-hmm.
It's there already, so you can get started. I'll
And
give you guys
to
10,
finish before the class finish. Or...
inshallah. Yeah, you should be able to. All right, try and get it finished. There's only 20 questions. Work with your friends. We'll compare. Okay, actually, no, inshallah. Get it done. All right, we'll save inshallah for next time.
Yeah, I was
Okay, all right. So class has been awesome. And what am I going to do now? I'm going to stop recording. Am I going to stop? I'm going to pause.